Hello everybody, and welcome to example 2 on page 61 of the workbook. Here's another example of using implicit differentiation to find y prime. Okay, and what's going to be different in this example is that we're going to use a shorter method of finding the derivative here. Okay, so we can shorten this process that we've been using to find a derivative using implicit differentiation. So in future problems that you do, you're going to have your choice over the longer way of doing it or the shorter way. Each way has its advantages, and so you can decide which makes the most sense to you. Okay, so to illustrate this, I want to scroll up and look at the example that we just completed, just to illustrate the shortcut that we're going to take. The shortcut that we're going to use in example 2 is going to take us all the way from here, okay, the equation, to this step. So what it's going to do is to bypass this process of letting y equal f of x. That's technically not necessary. We can get by without doing that. The only catch is that we're going to need to remember in this shorter way of doing it that every time we see the variable y, it's really representing a function. Okay, and we're going to have to treat it accordingly. Okay, so with that in mind, let's see if we can apply a shorter method to find the derivative in example 2 here. Okay, so what we'll do is start by taking the derivative of both sides. Okay, this time though, we're not going to relabel our y. We're going to leave it y. We're not going to write f of x. Okay, looking at the left-hand side, notice that we've got a product, 4 cosine of x times cosine of y, so we're going to need the product rule there. So let's see, we'll have the first function times the derivative of the second, plus the second function times the derivative of the first. Okay, and over on the right, we need to take the derivative of 3 times y. Okay, so the 3 is a constant that we can factor out. And if you take the derivative of y, you're just going to get y prime. That's what y prime means. Okay, and so going back to the left-hand side here, first derivative that we need to take is the derivative of cosine of y. Okay, so let's start by just rewriting the 4 cosine of x. Okay, when you look at cosine of y, remember that the y that you see there is really representing a function. Even though we didn't rewrite it as f of x, it represents the function f of x, and so when we see this y, we have to really think of that as being an inside function. It's like a u, so we really need to use the chain rule when we do this derivative. So first question we ask ourselves is what happens if you take the derivative of cosine of u? Well, you're going to get negative sine of u, and our u is y. And then there's that second step to the chain rule. We're going to multiply by the derivative of the u, which in our case is y, so we're going to get a y prime at the end of that. So negative sine of y times y prime is what we got for the derivative of cosine of y. Okay, and continuing on here, we've got a cosine of y, and now we need to take the derivative of 4 cosine of x. Okay, that's just going to be negative 4 sine of x. That's an ordinary derivative because it just has x's in it. Okay, and over on the right we've got 3y prime. Okay, let's simplify a little bit here. So this negative sign, I'm going to take that and just move it to the front. And just make the algebra a little easier here. So we're going to get negative 4 cosine of x sine of y times y prime. And I'll do the same here. So this minus sign can move to the front. Turn that into a minus 4 cosine of y sine of x. Okay, we wouldn't have to do that, but it's a little bit more natural maybe to have those minus signs at the front. Okay, and remember what we're trying to do here. We would like to take this equation and solve it for y prime. Okay, we're going to use the same technique that we did in the previous example. We're going to try to get all of the terms that have y primes in them on one side of the equation by themselves. Okay, so what we'll do, well, let's first find the terms that have y prime. There's one here, and then there's one here. Okay, so what we'll do is to take that negative 4 cosine of x sine y prime and just add it to the right-hand side. Sorry to write so small on you here, but space is a little bit tight. Okay, so we'll add that to both sides, and what we're going to get then on the left-hand side is negative 4 cosine of y sine of x. That's the only term that's left over there. And then over on the right, 3y prime plus 4 cosine x sine y times y prime. Okay, and since the terms on the right-hand side, we've got all of the terms that have y prime in them on the right-hand side. Now we can factor. Okay, so I'm going to just rewrite the left-hand side, and then on the right, we'll pull out a y prime, and we're going to get a 3 plus 4 cosine x sine y. Okay, and can you see the last step here? Okay, we want to get the y prime by itself, so we're just going to divide both sides by the entire expression, 3 plus 4 cosine x sine y. All right, and let's see if we can write our final answer up here. All right, so over on the left, we're going to get minus 4 cosine y sine x. We divided that by 3 plus 4 cosine x sine y, and all of that is equal to y prime. That's what we wanted to solve for. Okay, and there's our answer.